Dear students, today we are going to derive the famous mirror formula. I hope you all have read it in class 10 as well, but still I believe that we must revise it if you already know it. Well, we have considered an object AB which is placed in front of a concave mirror. And we take two rays. One ray is taken to be parallel to the principal axis CP and another ray is along AP. Now you already know that any line passing through the center of curvature of the mirror is nothing but normal at that point at which the line intersects with the circle. Therefore, whatever angle APB is nothing but angle of incidence, and so we have mentioned it by symbol I. And since PC is normal and PA1 is the reflected ray, therefore angle BPA1 is nothing but angle of reflection, and we have denoted it by small r. Well, you see, these two rays, the ray parallel to the principal axis must pass through the focus, and these two, the ray reflected from point P, both meets at point say A1, which lies somewhere in between the center of curvature and the focus of the mirror. Now I have drawn another line red, shown by the red color. Well, this is the third possible ray which we could have taken. That is, a ray which is passing through the center of curvature will retrace its path. Why this happens? Because any ray, any line, any ray passing through the center of curvature is essentially incident normally to the surface, and any ray incident normal to the surface will retrace its path. So if we would have considered this line AC as the ray selected, then that would have also brought the same results. That means the image shall form at the same point, whatever be the choice of ray. You never get confused that if we change the choice of ray selected, our image position may alter. That is not really happening. Here you can also see it. So now we consider the two triangles which are similar. One triangle is A1B1F, A1B1F and MPF. Another triangle is MPF. You see here it is M, P and F. This part, M, P and F. And we have considered first triangle A1, B1, F. So here we have A1, this is A1, B1, F, and this is MP, F. Now we consider these two triangles. These are similar because the vertically opposite angles are equal. So this angle is equal to this angle. I mean angle CFA1 is equal to angle MFP. So these two angles are equal. One angle is 90 degree here. One angle is 90 degree here. And therefore these two triangles are similar, and so we can write for similar triangle the side ratios are equal. Therefore we have A1 B1 equal by P1, A1 B1 by PM by PM is equal to B1F. Here it is B1F, B1F divided by PF. And as we see that PM is nothing but nearly equal to AB, is equal to AB, exactly equal to AB, because AM is parallel to the principal axis. So we have PM equal to AB, and therefore we get this format: A1 B1 by AB equal to B1F by PF. Let us call it equation number 1. Now we again use another similar triangle A1 B1 P, and similar triangle ABP. Here you see we have, this is our principal axis, A1 B1 P, and the bottom one is A1 B1 P. This is A1 B1 P, and this is ABP. So you see these two triangles are similar. How? One of the angle is 90 degree, and angle of incidence is equal to angle of reflection. So the third angle automatically becomes equal, and therefore these two triangles become similar triangles. And once they are similar triangle, their side ratios must be equal, and therefore now we have A1 B1 by AB, A1 B1 by AB equal to B1 P by BP. You see B1 P by BP, and equating, we call it, let us call it equation number 2. So now equating 1 and 2, what we have, A1 B1 by AB is common in both, so we have these two factors, B1 P by BP equal to B1F by PF. Now B1F, what is B1F? You see B1F is the distance between B1 and F, that we can alter and write equal to, we add FP in it, so it becomes B1P, and subtract, you see B1P is nothing but, B1P is nothing but the B1F is, B1P by BP is equal to B1F by PF. So we are going to now replace the value of B1F. What is B1F? Let us see. B1F is this distance. So what we do is we add PF in this length. It becomes B1P, and since we have added, so we must subtract the same amount. So we have added PF, so it became B1P, and minus FP will again become equal to B1F. So for B1F we have written B1P minus PF, and already PF was there, so we got this final relation, B1P by BP equal to B1P minus PF by PF. I believe there is no confusion. We have replaced the value of B1F in terms of B1P minus PF. You can verify it from the diagram. This length is written as added to this length is PF, and then subtracted this length PF. So it becomes B1P minus PF. B1P minus PF. Now using the sign convention, we have already talked about the sign convention. What is sign convention? That all distances, you must remember this always, all distances are to be measured from the optical center or pole. All distances measured along the incident ray are taken to be positive. All heights measured above the principal axis are taken to be positive. So here you see in this relation, what is B1P? B1P, this is the distance of image. So you start from point pole, you point, keep the 0 marking of the scale coinciding with point P and move in this direction. That means you are moving against the incident ray, therefore image distance is negative. B1P is minus V. About BP, image object distance, you keep the 0 scale at point P and move towards B, that find the distance BP. This again you are moving against the incident ray, so you are having BP equal to minus U. And also for measuring the focal length, you keep the 0 of the scale at point P and move towards F. You move against the incident ray, so focal length is also PF. PF is nothing but focal length. Focal length is also negative. So now we got these three values. You put in this equation. You got this equation, and when you solve it, you get something which is in the numerator. That means VF equal to UV minus UF. If we divide both the sides by UVF, we get on cancelling these factors which are common in numerator and denominator. Here VF is cancelled, so you got 1 upon U. Here UV is cancelled, so you are left with 1 by F, and here UF is cancelled, so you are left with minus 1 by V. Now you got this relation, and if you rearrange it, you get 1 by F equal to 1 by V plus 1 by, this is nothing but mirror formula. This is nothing but mirror formula, where F is the focal length of the concave mirror or any spherical mirror, and V is the image distance, and U is the object distance. Well, students, whenever you apply this formula, you have to again feed the value of these factors, whichever is known to you, according to the sign conventions. You must remember it. And sometime it happens that you might be asked to prove this relation for using a convex mirror instead of concave mirror. Well, I have given you the diagram, ray diagram, which you have to adopt, and then here I explain you. Here I have taken an object AB and it is placed in front of a convex mirror, and we have taken two rays. One ray is we have taken two rays. In fact, third ray is also there, but we need only two rays at a time to have our formula proved. But still, you see this one, this ray AC is not required, but anyway I have given it. You see, you have two rays. One ray which is AM parallel to the principal axis, after reflection appears to be coming from focus. It appears to be coming from focus. That means when you retrace it, the path, it will pass through the focus. We take another ray AP which is making eye angle with the principal axis. After reflection, it passes in such a way that it makes same angle with the axis BP, and therefore because these two must be equal according to law of reflection. So once you got this situation, you see when you retrace the reflected ray, this reflected ray, AM reflected ray, and the another ray is this one, ray AP after reflection. If you retrace these two rays, what will happen? You will get the image formed, virtual image formed at point A1, and hence the image of AB at A1 B1 will be formed. Now one thing you have to consider over here, that vertically opposite angles are equal, and so you use this similar triangle ABC, and a similar triangle A1 B1 C. A1 B1 C. Same angle is common for both, perpendicular one angle is perpendicular in both the cases, therefore these are similar. Also we use another triangle, similar triangle ABP. ABP is similar to triangle A1B1P. A1B1P and ABP are similar triangle. Why we say? Because if this is angle R, the vertically opposite angle is also R, and I and R are equal, therefore these two angles are equal, and one of the angle is perpendicular in both these triangles, so we again get the two triangles are similar triangles. And then on using these two similar triangles in the same fashion what we have done over here, we get this relation. Once we get this relation, you have to again apply the sign convention and solve it taking R, that is radius of curvature, which is PC. For radius of curvature PC, you have to take 2f. So once you have done this homework, you will be able to derive the same relation for mirror using the convex mirror. I leave it for you as a homework. Thank you and have a nice day.